Welcome back. You may have thought we'd finished the first part of Chapter 8 on rates and equilibrium, but I thought we'd do a bonus summary lesson, you're welcome, on factors that are affecting the rates of a reaction. So this is all going over the stuff that we've already done. You don't have to write this down if you don't want. You've already done it, but you may want to go through and see which bits you need to double check and which bits you need to familiarise yourself with. So these are the factors affecting the rate of reaction, a summary. Start right at the beginning. What did we say? Reactions occur when, what did we say has to happen? The particles collide with enough energy. Got the picture there showing the collision theory. Got those red and blue particles, they are colliding with enough energy, they are going to react. Now, right at the start we said about the speed that reactions happen. We said all reactions, they start fast. Then what do? They slow down. And finally, they stop. Why did they start fast? Why are reactions always fastest at the start? Because there are more particles to collide. At the beginning, there's more reactant particles. There's going to be more frequent collisions. Then why does it slow down? The reactant particles are being used up. Why does it finally stop? Because there are no particles, no reactant particles left to collide and react. So that's how reactions proceed. Then we're going to talk about the factors affecting the rate of reaction. So we jump first of all into surface area, or surface area to volume ratio. We said the larger the surface area to volume ratio, the faster the reaction. The diagram. With a high surface area to volume ratio, the pieces are smaller. So if we had a solid, if we crushed it up, we'd have a higher surface area to volume ratio. Can you remember why it will be a faster reaction if we had a higher surface area to volume ratio? What can we say about the particles? There aren't more particles. It's the same number of particles on both sides, but more particles are exposed. And if more particles are exposed, there are more frequent successful collisions. Then we moved on to concentration. The higher the concentration, the faster the rate of reaction. Look at the left and look at the right. Now you could say on the right, whereas the higher concentration, you could say there's more particles, but saying that is not enough. On the right, there are more particles in a given volume. So what's the consequence of that? Again, there are more frequent successful collisions. Pressure was very similar. The higher the pressure, the faster the rate of reaction. On the right, with a higher pressure, there are more particles in a given volume. So what? There are more frequent successful collisions. Then we moved on to temperature. The higher the temperature, the faster the rate of reaction. Now this time, what hasn't changed? The number of particles in the volume hasn't changed, but now, at a high temperature, the particles have more energy and move faster. So what? So what that they have more energy and move faster? There are more frequent successful collisions. And also, more collisions have the activation energy. That's why more of them will be successful. So this is the only time we mention the particles having more energy. Finally, we could add a catalyst. What is a catalyst? Catalyst is a substance that speeds up a reaction without being used up. So we can recycle and reuse a catalyst. We can use it over and over again. It speeds up a reaction. How does it do it? How does a catalyst work? It lowers the activation energy by providing an alternative route. Catalyst lowers the activation energy by providing an alternative route. We had a diagram, an energy level diagram, to show this. Originally, without a catalyst, we'd have to put a certain amount of energy in, the activation energy, the minimum energy needed to start a reaction. If we didn't put that energy in, if we didn't get to the top of the blue line, with energy, the reaction wouldn't happen. But if we added a catalyst, there'll be a lower activation energy. We've found a new route for the reaction that we don't have to go as high as the blue line. We only have to go to the red line now. There's a lower activation energy, so the reaction will be faster. Importantly, we do not give the particles more energy. We do not give them more energy by adding a catalyst. All a catalyst does is lower the activation energy. So that's a quick, useful summary, I think, of the factors that affect the rate of reaction. Any questions? Get in contact with your own teacher. Hopefully that makes sense, and I'll speak to you shortly.